If you're an iOS developer and you've spent any time with storyboards, you've typed at IOutlet and at IBAction hundreds, maybe even thousands of times, right? They're kind of the fundamental glue between your beautiful designs and your actual code. But have you ever just stopped and wondered what's really going on under the hood?
I mean, really, think about it for a second. You're in this visual editor, you drag a little line from a button over to a completely different file, your Swift code, and boom, it just works. How? How does that connection actually get made?
Honestly, it feels like a straight-up magic trick. There are no import statements, no obvious code linking the two worlds together. But, it's not actually magic. It's just a really clever system. And in this explainer, we're going to pull back that curtain and show you exactly how the trick is done.
So let's start with the first piece of this puzzle, the thing that gives you a handle to all your UI elements, the good old @outlet.
So what is it really? Well, at its core, an @outlet, and that stands for Interface Builder Outlet, by the way, it's just a special keyword. It's a little flag you put on a property in your Swift code that tells Xcode, hey, this variable right here, this isn't just any old variable. It's a direct line to a UI element that I designed visually over in the storyboard.
And why do we need that direct line? Well, this is how your app actually comes to life. With an @outlet hooked up to a label, you can change the text to update a score. If it's connected to a button, you can change its color when it's disabled. You can hide or show an entire view. It's your bridge from the brain of your app, your code, to what the user actually sees on screen. Okay, now for the big reveal. Here's how the magic actually works. The connection isn't made when you build your app, not really. First, when you build, your pretty storyboard gets compiled into a much more efficient format called a nib archive. Then, when your app is actually running and it's time to show that screen, UKit loads the view from that archive. And finally, this is the key, the system looks at your code while it's running, finds that @IOutlet tag you wrote, matches it up by name, and then physically wires it up to the live UI object. It all happens on the fly. Now, you've probably noticed you almost always type the word weak next to an @IBOutlet. That is super, super important. Think of it like this. The main view holds on to all of its subviews, like a button, with a strong grip. If your view controller also has a strong grip on that same button, they end up holding onto each other in a death grip, and neither one can ever be released from memory. That's a classic memory leak, called a retain cycle. By making the outlet weak, you're basically telling your view controller, hey, just have a light touch here. It breaks the cycle and keeps your app's memory nice and healthy. All right, so now we can grab our UI elements and change them. But what about when the user wants to do something? Let's flip over to the other side of the coin, the @action. An IBAction or Interface Builder Action is a completely different animal from an outlet. It's not a property that holds on to something. It's a method. It's a function that you've marked as, hey, this block of code right here, I want it to run when a user does something specific, like tapping a button. Yeah, so if @IOutlet is all about what the user sees, @IBAction is all about what the user does. It's the hook where you hang all of your app's logic. A user taps that login button, and the @IBAction is what kicks off, grabs the username and password, and tries to sign them in. It is literally the action part of an interactive application. And the way this works is just a classic, brilliant design pattern called target action. The storyboard, it doesn't really know about your code in detail, but it stores a little reference. It knows the target, that's your view controller, and it knows the action, that's just the name of your function. So when the user taps the button, UKH just looks up that reference and sends a message, kind of like, hey, target, do this action, and your code runs. Simple as that. So we've seen how these two pieces get wired up behind the scenes. But why does digging into this stuff actually matter? Well, because understanding this foundation is like having a master key. It helps you build, debug, and really get a handle on UI development. This table just lays it all out, nice and simple. An @outlet connects a UI element to a property in your code so you can access it. An @action connects a UI event, like a tap, to a method so you can respond to it. Honestly, the easiest way to think about it is this. An outlet is a noun. It's a thing. An action is a verb. It's something that happens. So look, if you take away just one single thing from this, let it be this. Both @IBOutlet and @IBAction are just markers. They're little signals you leave in your code for Interface Builder to see. The actual connection, the wiring that makes it all work, that doesn't happen when you build your app. It happens at runtime, at the exact moment that screen is loaded into memory. And knowing this isn't just for fun, it gives you real-world developer superpowers. Seriously, when your app crashes because an outlet is nil, you'll immediately know, it's a runtime wiring problem. You'll truly understand why that weak keyword is so critical for avoiding memory leaks. And honestly, this knowledge gives you the perfect mental model to confidently move into building user interfaces entirely in code, because you already get the principles that are happening under the hood.
Look, demystifying our tools is what lets us build better, stronger, more reliable apps. The magic isn't really in the tool itself. It's in understanding how it works. So, with the curtain pulled back, the only real question left is, what are you going to build next?